Hello class, welcome back. Today we're going to go ahead and continue on section 6.3, the central limit theorem. All right, and it's going to be very important for you to know the definitions in this section. All right, for you to, right, by now we should have already skimmed, we should have already read this section in the book. Right, you want to focus on the definitions, right, not memorizing them, but know, right, and know them. All right. So go ahead and take time to go ahead and you may pause the video and read the definition for the central limit theorem, right? Right, and this what this pretty much is stating, right? Um, that the mean we are extracting comes from a larger population, right? So this is where things are going to differ quite a bit from 6.1, 6.2 to 6.3, right? There are keywords you're looking for, right? So for on section 6.1, 6.2, right, we were using z is equal to that x value you're focused on minus the mean over the standard deviation. All right. For here, right, it's going to be right. You're going to look for a keyword, right? You're looking for the keyword that's saying that the sample is taken from a larger right, a larger population. So this here is going to be z is equal to still an x values that you're focused on, right? But I'm just writing it a little bit differently. Minus the mu over, and then the standard deviation, right, for this section is going to be standard deviation divided by the square root of the sample size, right? And you go ahead and see this part here written differently, right? This part there is known as your standard error, right? And you may see it written as sigma over square root of n, or the square root of the variance, right, over n. And how is that possible, right? How are these the same? Well, I know that if I'm just focused on the variance, all right, let's go ahead and make this a little bit larger, right? Variance over square root of n. This is the same thing, right? I can apply the square root property to everything individually, right? And the squared and the square root of n cancel out, meaning I just have this, all right? So the only thing is to be careful because for the test, I may give you the standard deviation or it may give you the variance, right? If I give you variance, right? So in other words, if you're just using this formula, that's fine. All right, if you're just using, oh, I did not like that color. It's a little bit too dark. There you go. You can see through it. All right, if you want to just memorize that one, that's fine. All right, just know that if I were to go ahead and say, hey, your variance equals 25, you know that your sigma, all right, is just the square root of that, all right? So meaning the standard deviation you would be using is 5, right? So you would go ahead and plug that in instead, all right? So 5 over whatever the sample size is, all right? So right there. So keep an eye on out for those. And I'm only going to do about 3 of them, right? One to get the full idea of what exactly is it that we're doing. And right, and the method is pretty much the same, right? You find your z values. If you're asked for something less than, right, you're going to read the z score as is, right? So let's go ahead and get started with number 1. All right, example number 1 states the average number of moves a person makes in his or her lifetime is 12, all right? So a lot of information is already given to me. So this is going to be my mu, all right? This is mu. The standard deviation is 3.6. So in other words, my sigma is 3.6. Assume the sample is taken from a large population. That right there is the keyword that I'm looking for. And the correction factor can be ignored. Okay, there are 2 things here, right? And we'll see on the next few examples what happens if that large population is given to me, right? And the correction factor is not ignored. What do I do then, right? Round the final answer to 4 decimal places, all right? So they're telling me for part A, right, I am looking for, find the probability that the mean of the sample is 25, all right? The mean of my sample is 25. people is less than 10, right? It's going to be less than 10. So I know my 25, right? And it's less than 10, right? So it's going to be the X value I'm focused on. That here's going to be 10, all right? So I'm going to go ahead and plug this in, right? Let's go ahead and plug this into my formula. And so something you may want to do first is, right, is find the standard error first, right? Standard error, right? You want to go ahead and take step by step, right? Let's go ahead and find the standard error. This is going to be 3.6 over root 25, which is 3.6 over 5. And let's see what that standard error ends up giving me, all right? All right, I end up getting 0.72. Right, so in other words, z is equal to x bar minus mu over sigma over root n. This is going to be 10 minus 12 over 0.72, which is negative 2 divided by 0.72, right? Right, I get here, my z value is going to be negative 2.78. All right, my z value is 2.78. Right, and we're going to use our z table, right? And we find out the negative 2.78 right here, right? 0.0027, 0.0027. Right, so the probability of that, right, or to be more specific, the probability with x bar being less than 10, right, is 0.0027, right, or 0.27%, right, 0.27%. And that's pretty much what we're doing, right? So the only addition step here was that we are not dividing this by the standard error, all right? We're now dividing this by the standard error. And as you can see, right, if you're watching this, hopefully you're watching this, I'm giving you a lot of practice, right? Giving you a lot of these problems for a reason, all right? You may be saying, hey, it looks like it's the same thing. Yes, right, but learning how to decipher the question, right? Right, and this, right, it is going to be greater than, right? So you're looking for something greater than 10, right? So you know that once you find that p-value, right, once you find the z-value, once you find that z-value, it's going to be 1 minus that probability that you found, right, as a refresher. And then bounded between, right, you're bounded between two values, between 11 and 12, right, you find those z-values and you're going to do the large one minus a small one, all right? So in other words, you're finding the probability that is bounded, bar is bounded between 11 and 12, all right? The one for part C. Right, so let's go ahead and go on towards example 2. Right, the ages of proofreaders at a large publishing company, the mean age of proofreaders is 36.2. Right, so they're already telling me my mean. Right, and the standard dev of 3.7 years. Assume the variable is normally distributed to around 3, right, around to the specific values stated there, right? So this is all I've given so far, right? So for part A, they're saying if a proofreader from the company is randomly selected, find the probability that his or her age will be between 37.5 and 39, right? 37.5 and 39. Right, so right, and this is why I said you need to be careful with the information I'm giving to you, right? You may be asking, hey, I didn't see, they didn't give me a sample size, all right? They gave me a sample size. They didn't mention anything about a large population, or, that I am able to ignore the correction factor, right? So this here is going to be just right, you're finding regular Z value, all right? This is all I'm giving, and that's fine, all right? So this means Z1 is going to be X minus X1 mu over standard deviation. It's pretty straightforward, right? All right, so this is going to be 37.5 minus 36.2 over, what is that, 3.7? Right, over 3.7. This here, I end up getting 0.35. All right, for Z2, right, I have X2 minus mu over standard dev. My X2 is 39 minus 36.2, well, over 3.7. I'm sorry about that, over 3.7, right? And I end up getting 0.76, right? 0.76. Right, and what do I need to do now? I need to go ahead and find these values, right, on your to find these probability values on your Z table, all right, on your Z table, table E, and you'd find out, right, that for the first one, for Z equals 0.35, you get 0.6368, right, and whenever I pull it up on the other one, right, because I have my notes here, right, I get 0.7764, right, and since you're finding an area between, right, an area between, it's going to be P2 minus P1, right? What's that going to give me? That is 0.764 minus 0.6368. When you calculate this, this should give me 0.1396 or 13.96%, right? So that's the difference between this one, right? So in other words, I may still ask you something from the previous two sections in this part here, right? So this here is part A. For part B, right, I'm still going to use the same thing that was given, right? So my mu equals 36.2, and my standard deviation is 3.7, right? I'm told here that if a random sample of 26 proofreaders is selected, right? So I know that's going to be my end. Find the probability that the mean age of the proofreaders in the sample will be between, okay. So in other words, my X1 is 37.5, my X2 is 39. I'm asked to find the probability between X values 3.5. 9, right, and right. Assume that the sample is taken from a large population and the correction factor CF can be ignored. All right. So that means I'm going to find Z1 is equal to X bar 1 minus mu over standard deviation over square root of n. And then I'm going to find Z2, right? X2 minus mu over standard deviation over square root of n. All right. All right, let me go ahead and plug in Z1, all right? Your standard error here, all right? Let's go ahead and find standard error. Standard error equals sigma over root n, all right? This here ends up giving me 3.7 over root 26, and this here ends up giving me 0.726. All right, so Z1 is going to equal X1, which is 37.5 minus mu over standard error. My standard error was 0.726. And when we solve this, right, when we go ahead and solve this, right, you should get 1.79. Right. We're going to go ahead and do the same thing for the other side. And I already know my standard error, right? You know my standard error. The only thing that's going to differ here is my x bar 2, my x2 bar. This is going to be 39 minus 36.2 all over 0.726, right? Meaning Z2, Z2 would be 3.86. And remember, we're finding the probability, right? So the one thing I was seeing a lot was these values were subtracted beforehand, right? So let's not do that, right? Do not subtract these here, right? And then find that value. Find the probability value that corresponds to this on your cheat sheet, I'm sorry, on your Z table, right? On your Z table. You find out that for 1.79, I'm gonna get 0.9633. It's gonna be on the bottom half of that sheet, right? On the positive side. And then for P2 for 3.86, you find out this is pretty close to the edge, right? Pretty close to the edge. I'm going to do P2 minus P1, all right? And here you're gonna get, plug those in, you'll get 0.0366 or 3.66%, right? 3.66%. So, right. So for the most part, it's still pretty similar, right? It's still the same process: finding the Z value, find out what you're asked for. Is it less than? Is it greater than? And also deciphering, hey, you know, is there anything there mentioning, where was it? Large population and correction factored, ignored, right? We're going to go ahead and continue with the last example. All right, N of N, the correction factor, right? So reading the question, life expectancy in a study of a life expectancy of a population of 500 people. Ooh, okay, that sounds familiar. We haven't seen something like this in a while. Let's go ahead and make this a little bit larger. Go ahead and move it here. All right, 500 people in a certain geographic region. The mean age of death was 72. Right, with a standard dev 5.3. If a sample of 50 people from the region is selected, all right, so we find out that, hey, there was a larger sample that they gave me in the beginning, right? A population sample. That there is going to be large N, all right? Large N is 500. The sample extracted from there, all right, is going to be 50. Find the probability that the mean life expectancy would be less than 71.3, all right? So in other words, less than 71.3, meaning I have to find the probability for X bar being less than 71.3, all right? Wow, right? I didn't see here anything that meant that said you can ignore the correction factor, all right? So this is going to be a big part, right? This is going to be a little bit different, all right? I do have the formula ready here. These notes earlier, right? So the formula you're going to be using here, right? When you see that they give you 2 of these samples and you make the decision that, hey, they do not say that I can ignore the correction factor, right, from their large population. It's going to be Z, right, is equal to X bar minus mu, right, over your standard error times, right, the correction factor, right? So now I'm not going to ignore this, my correction factor, all right? You know what? Let me go ahead and type it in with a different color. We'll do the, all right, this correction factor, right, is going to be large N minus small n over large N minus 1. All right. So let's go ahead and solve everything so I can just plug it in, all right? Let me find my standard error. Standard error is going to be sigma over root n, which is 5.3 over root 50, right? Let's see what that ends up giving me. 5.3 divided by root 50. I'm going to get 0.2 decimal places and then round to the very end at 4, right? So this is going to be 0.75, right? And then I'm going to look at my correction factor. Right, my correction factor is going to be the square root of capital N, uppercase N all right, minus lowercase n over 500 minus 1. All right, so in other words, this is the root of 450 over 499. All right, let's see what this correction factor is. Get 450 divided by 499. And this correction factor is 0.95, right? 0.95. So now I can go ahead and plug everything in, right, to my z value. My x bar is 71.3 minus 72 over, right? I get 0.75 times 0.95. So let's go ahead and do my numerator first. All right, this is going to be negative 0.70 divided by 0.7125, right? And whenever we go ahead and plug this in, we find out, right, this has to be 2 decimal places because that's the only thing, that's what I'm able to find. Whenever I'm looking at these z values, right, my z value is going to be negative 0.98. Right, negative 0.98. So I'm going to go ahead and pull this up on my z table, right? So the probability value that corresponds to this, right, is going to be 0.1635, right? And since it's, and if you remember here, I wrote it down here, and this is why I write it down, right, in case I'm running short on time or I just can't find it when I'm reading it, right? It's less than, right? So it's less than, so that means I'm going to take this probability value as is, right? So in other words, my probability is 0.1635 or 16.35%. 16.35%. All right. On the previous 2 sections, right, I had a problem where you were giving the percentages. Remember on the previous problem, you were giving percentages, all right? So yeah, in other words, I gave you the p-value, all right? You then have to go ahead and find the z-value that corresponds to those endpoints, all right, and so forth. In other words, you're going to have something like that over here as well, where you're going to be giving everything except x bar, all right? So in other words, I would give you a percentage, right? So in other words, I would give you something like, all right, or you have to find for you have to solve for x bar, all right? I'm going to go ahead and give you a probability, all right? Probability. You then have to go get this probability, find your z value that corresponds to that probability, right? You would then plug in that value in here. You're going to have your mu and your standard error already computed, right? You plug everything in and then you just solve for x bar, right? So it's still going to be the same process, right? The only thing is that it's not just going to be sigma in the denominator, right? It's going to be the standard error sigma over root n, right? And that is all I have for you all today. Like I said, this is just a continuation of 6.1 and 6.2. If you have any questions, please don't hesitate to ask, and I'll be more than happy to help you. And thank you very much for your time, and I hope you enjoy the rest of your day. Thank you.